the wonderful thing about these topics is that they are so interwoven, and we have 5 experts here today who are going to be able to talk about subjects that are near and dear to their heart and to each of these technologies, but also engage with each other and have a lively conversation about how all of these really futuristic technologies are actually here today, and about how they intersect with each other. So I'm really excited to welcome our panelists, and I'm going to have them briefly introduce themselves because they're going to do the best job explaining what they do. And let's start with you, Justin.
I'm Justin Fishkin. I'm the Chief Strategy Officer of Local Motors.
I'm Jim Mault. I'm the Chief Medical Officer of Qualcomm Life.
I'm John Phelan, and I manage the San Francisco Bluemix garage for IBM.
I'm Ryan Pamplin from Meta, and I run partnerships and content and sales.
I'm Shiva with Intel Capital. I invest in sports and healthcare and a few other verticals.
It's a really great crew, and we were having a fun time talking backstage about what's going on in this world right now. And the first thing I want to start talking about is digital assistance, and that's digital assistance with a T, right? I mean, you all experience digital assistance with a C every day. We all have phones. We all get our assistance through technology every single moment of every single day. Assistance with a T, we're talking more Siri, Alexa. You all use these types of assistants. They're becoming ubiquitous, but that type of assistance comes from this deep AI background, and there's a lot of really interesting computer work happening to make those products successful for consumers. I want to have John talk just a little bit about IBM, the background and the computing that happens to make that kind of interface with the digital assistant a reality, because I think it's going to set the stage for this entire conversation and all 5 of these technologies. So John, tell us a little bit about the deep background of digital assistance.
Sure, great, thanks, Lindsey. I think I don't want to get too geeky, but I'll give you a couple of things to think about that might give some ways to match how you would apply different solutions or problems to it. So there's really, I'd say, 2 elements to it, and many of you perhaps remember seeing the Jeopardy game and how IBM Research designed an implementation of Watson, which is the underlying technology, to play Jeopardy really well. Keep in mind that that was a one-time deal. In fact, it looked like a Jeopardy game, but in fact, it was so custom that it required that all the participants come to the IBM lab because all the servers were there and everything was configured exactly right. What's been happening since then is it's becoming more and more generalized and more open to integration from all other types of technologies. And so that's where we're beginning to get into that cusp, which is a good time for this kind of dialogue. Underlying it, though, is 2 factors I'll mention, and they interrelate. One is the algorithm and how you manage the algorithm, and the other is the data. And not only how you select and bring the right data to bear, but then how you manage it, moving it back and forth. And so as you begin to think of those 2 things, you see that as the technology matures from being sort of a one example technology, it becomes how I take that and break it into a set of different APIs, and that is what we've been doing with Watson on the cloud. And then once you've got those APIs, how do you tune those algorithms so that they give you relevant answers? And this gets to Lindsey's questions about assistant. So think of a spectrum when you call your phone company and some voice is talking to you, but it's really just asking you to press 1 or 2 or 3, right? It's not very intelligent, right? Even though it's doing some voice recognition, it's really not much, there's not much T in assistant, right? And then evolve towards the future, and you begin to think of algorithms as a good example. Search is one area where for companies like Google took it one step beyond the human curated of Yahoo, for example, right? And so that's what you're beginning to see generalize now, so that any of us can then think of an experience, a use case, an assistant scenario, and map that to both the algorithm and the data. The one comment I wanted to make about data is that for an answer to be relevant, you need a reference set of data, we call it a corpus, that makes the algorithm actually generate probabilities that make sense and are relevant to you. So selecting that data is the basis for how Watson or any AI would learn. And learning, I think, is really the next generation, the next big challenge, because without automatic heuristic learning, then you don't really have the I part of AI. So I'd say that we are at the beginning stage of that. You can, for example, teach Watson. Watson can learn. But we still have more iterations to do to make that happen autonomously.
And I think right now we're using voice in many cases and typing to interface with systems like this. But I think that there are future ways to interact with a digital assistant, some of which may not even require prompting it.
That's correct.
And I'm sort of curious about that. I'm curious with the other panelists, how does this affect your industries? Does anybody want to jump in and comment on what you're thinking about in terms of that interaction and how the user prompts it or not?
I think when you look at where the paradigm of computing is today, I can look out and see a bunch of you on your laptops, on your phones. These are devices that really suck us in and kind of distract us from the real world. The future of computing, no matter who you ask, I think is a digital layer on top of our real world that's contextually relevant to us, to our environments, to each other, to the objects in the world. And I think, the assistant today is also a new paradigm where you interact with your voice. When you go a step further, when we're talking about 2020, where we're all walking around with this strip of glass on our eyes that ultimately displaces the devices you're using right now, I think that's when the assistant comes into play. I look at an object, maybe I'm on a diet, I look at food and it tells me, okay, this is how many calories it is, and this is how many grams of protein, whatever, and it keeps track of these things for me. So it starts to integrate into my life in a way that only an intelligent human could, but because there's a great set of training data, you now have this great experience that feels like it's a human. Your algorithms are only ever going to be as good as the input data, the training data.
Exactly.
Jim?
Well, and I think healthcare in that regard is a vivid example of a disruption that's imminent. Our healthcare system for the past 2,000 years has been haphazard, it's been trial and error, and it's frankly been very uninformed. We really haven't had the data. Only in the last 5 years have we had an electronic record system for data to even collect. What you're about to see over the coming 10 years are the explosions in the Internet of Things are going to very immediately apply to the Internet of Medical Things, and the connectivity to all of that stuff, whether it's home diagnostic tests, drug delivery systems, biometrics in the hospital and in the home. And you'll see the data start to flow in healthcare that we've never had before, frankly. We never saw about the human body is generating about 20 million pieces of data per day. And in the intensive care unit, one blood pressure every half hour gets deposited into the record. So we're now with the ability to see that data, applying mathematicians and data scientists to do pattern recognition and actually see things about patients long in advance. We'll be able to see that you're developing symptoms of Parkinson's or arthritis literally years before a clinician would have ever recognized it.
So we're talking about like passively prompting an assistant system and some kind, and which is actually really, I'm going to switch our conversation just a little bit right now to transportation, because I think that this sort of passive observing of all of that data that comes from humans that we generate is going to be really important in the transportation setting. And Justin, you think about this kind of thing all the time. How are we going to take the information that comes from the environment and use it for things like self-driving vehicles, or for creating vehicles, or for getting data to the driver?
Yeah, so I mean, there's a lot of ways to answer that. But I can take it right back to IBM Watson. We just launched an autonomous mini shuttle that seats 12 people called Ollie. And you call it on an app, and it comes and it picks you up. And it's one of the first, I think, the first automotive integration of IBM Watson. And the types of things it'll do, it'll say, hey, Lindsey, you're late to work today, so I'll drop you off first. Or it'll say, Justin, do you want to get your Starbucks today? And that's just a simple thing. It'll learn as you use it. And literally, as we were just talking about, people are sitting in one of our microfactories training it, and in the garage training it to understand these things. And so that's a simple app, like a digital assistant type application. Just like the human body, vehicles give off an absurd amount of data for every mile they're driven, and people, what we're starting to see for things like Ollie or our 3D printed cars are data providers are now willing to subsidize the vehicles for the consumer in order to own that data, whether it's insurance companies or content providers or advertisers. And that's going to play out in a really interesting way, that vehicular, and we can talk about ownership and how that's going to work later. But that's the practical application for Ollie with us right now. It's going to do a lot more.
Can I add something to that?
Yes, please.
This ties together some of the things we were talking about, that I think we're now in the era where in manufacturing it was called, say, mass customization, but where it isn't just about one algorithm deciding which menu prompt you're going to choose when you call your phone company. It's now taking the algorithm and applying it to each individual and the entire data set associated with that individual, whether it be health or whether it be like the fact that you like to go to Starbucks and you were headed the same way home, but now you turned right, but you've gone that way before because that's Starbucks, and now would the car like to reroute? Yes, et cetera, right? So that's, I think, what's happening now is that it's bringing it to the individual.
And H&M wants to know if you're driving by their store every day.
Right.
We all know. I mean, we see this happening now, right? Like if you use mapping on a regular basis, your phone may tell you when you get in the car at a certain time in the morning, it's going to be 1 million minutes to get to work. But it's not that smart yet. And one of the other interesting things about the automotive industry and the consumer transportation sector, I think, is that there's a very long lead, right? It takes a traditional manufacturer, I think it's like a 7-year development cycle to get, so that's why you buy a new car and you sometimes feel sort of frustrated by the technology in the car because it doesn't seem to be up to date with this. Can you tell us a little bit about how all of this data is affecting the way we may end up manufacturing transportation?
Yeah, so I mean that's what we view at Local Motors as our primary disruption is the way that cars have been manufactured for 100 years. Essentially, communities around the world have been exporting jobs to import cars and exporting wealth to import fuels because they're tied so closely together. And so our thought really was if you can localize the manufacturing, if you can employ locals to make it, if you can do it at lower unit volumes and be profitable at lower unit volumes, then you solve this issue of we have to make 1 million units that are all the same or relatively the same in order to amortize that cost for our $1 billion factory. And so we're building small factories in communities that want them and want a specific vehicle, and we're making 3,000 units a year out of these facilities, and that really changes the game. That's why we're not the biggest car company in the world. We're not the most famous car company in the world, but folks like IBM Watson or NXP's autonomous Blue Box, they're integrating with us first because it takes us a month from concept to manufacturing of a vehicle, as opposed to 4 years, and that's why the technology in your car is always outdated based on when you compare it to what's on your phone. And so 3D printing takes it a whole another level. And for us, we're open source, we're crowdsourced, so most of our vehicle designers don't work for us. We pay them a royalty for ideas we use, and so and we'll talk about meta. So we're digging further back so that we're not making anything unless it's sold. And consumers are telling us what they want. I don't want to take too much time on this, but
no, I mean it's super interesting, and then it allows you, because it's sort of nimble, to think about how to use extremely current technologies. And I think this is probably a good place to transition a little bit to the conversation about augmented reality. But I'm sure that you think about that too. How can we layer the technology onto the driving experience And I'm just
Well,
curious
and the
what you think
design
about that.
experience, right?
Absolutely.
So because our cars are open source, it's like we're going to give you the 3D CAD right up front. So help us make it better, each unit that comes off the line. As well as we're not going to sell you a car or with an owner's manual. We're going to give you glasses for AR so that it can be serviced. The things that aren't mission critical can be serviced by you or by people in the field. But because we're local, you'll bring it back to us, and our cars are recyclable because they're made out of composites, and so we can just upgrade it to your next vehicle and put new technology in it. So I'm not trying to give an advertisement about local motors, but what I'm trying to suggest is the things that these guys are talking about, the data-driven world that we all live in, is changing hardware as much as it's changing software.
Absolutely. And Ryan, tell us, I mean, so we were talking backstage, you were talking about how augmented reality can apply to almost any sort of human scenario. Let's start with heads up and driving, but then just go. You have so much to say.
Sure, it's really interesting how rapidly the auto industry is changing. I think it's scary for a lot of the traditional manufacturers because folks like you are just blowing away the typical 7-year cycle. I mean, I was just talking to one of the head designers for one of the biggest car companies in the world and showing them a demo of Meta, and they were saying, this changes everything, because right now I design the car in 2 years. That's the first time I see a physical model of the car and get to experience it life size. And then 7 years from that initial design date is when I have the car in the driveway. And the innovation cycle is way too long. Tesla blows that away. I mean, they changed their bumper without ever even seeing a physical one. They only did it in 3D, then made the mold, then made the bumper and put it on the car, all within like 2 months. I mean, that is a crazy thing to have happen in the traditional auto industry. And then the extreme is what you guys are doing, and then integrating AR to actually use it to repair the car as an end user. That is extremely forward thinking. But why AR, right? I mean, AR is cool. I'm sure everyone thinks it's neat, but it's not for the sake of novelty, right? The whole point of AR is that it's going to enable us to break out of the confines of our screens. We are very limited. A lot of you are looking at screens right now that are very small relative to your field of view, and the worst part is that they're flat. And we're not flat. We live in a 3-dimensional world, and if you want to pick something up and grab it, you just touch it and you hold it and you know how to do it because you're human and you innately have this ability. If we can make our computers work this way, and we can put this digital layer on top of the real world, then you forget you're wearing the technology and you become one with this, content. And this will deliver a far more natural computing experience, far closer to real life than any machine that's ever existed before. That's the goal of AR, right? That's what we want to do, is have a deeper human connection with each other, with our environments, and the digital world than ever before. And I think auto is a great sort of early use case, but ultimately it's work, it's play, it's shopping, it's learning, it's communication, collaboration, and everything else except for swimming because it's not waterproof yet.
But it will be.
Someday.
Someday.
But I can't announce those kind of features yet, so.
As long as you.
I have a fast and funny story, and I would like you to tell me how AR would have helped me in this scenario. This is true. Yesterday, I was running late to work, and I had to run back into the house to get insulin because I am reliant on insulin. It's kept in my refrigerator. I ran into the house, I reached into the buttered thing, grabbed my insulin with my phone in my hand, grabbed the vial of insulin out, put the insulin boxes back, ran out of the house, and couldn't find my phone. So I had to make a decision, and I'd left it in the fridge. I had to make a decision between my life-saving hormone and my life. What would have happened if I had been interfacing with technology in a different way?
If you would have been wearing, the strip of glass that we're working towards, you wouldn't have a phone anymore, so you wouldn't need it.
You would be in the context.
I would not have left my face in the refrigerator. That's what you're saying.
If you took off your face and left it in the fridge, I don't know. I think at that point you should just give up.
Maybe the singularity guys will make it.
So what's a surprising use of AR? Something that maybe we've all heard of Pokemon Go. We've all seen children and some adults walking around, kind of layering this new reality on top of our reality, but still through this little screen. What's something even farther beyond that maybe this crowd hasn't thought of?
Oh, well. At first, I thought you were going to say, what didn't you expect? I was going to say Pokemon, but I mean, there's a ton of use cases that would really blow you away. One that maybe will surprise you because of its timing, but it's inevitable. I had the Minister of Education in China tell me recently that we have more students in our country than you have people in yours, and all of our students within the next few years are going to be educated using AR. So there's huge government push in China to have curriculum in AR, and they actually have an aptitude test, and they asked on the test this year, what will the impact of augmented reality and virtual reality be on the future of our world? So they have, hundreds of millions of students who are aware of it. You think Pokemon Go spread awareness for AR, this is on a much different level over there, and the students know, the parents know, so I think the adoption curve is going to be really fast, and I think that these young people are very tech savvy, and I think they're going to adopt the technology much quicker than a lot of other areas of the world, and I think the usefulness of learning spatially, right? We have proprioception. We understand our surroundings as humans. A textbook can never teach me about the human body in the way that a life-size model of it can, that I can pick apart and perform mock surgery on with a virtual scalpel. So I think the way we learn is going to dramatically change very rapidly, and I think we're going to get a lot smarter, a lot faster, and I think China, in a lot of ways, is going to make it happen faster than we are in terms of education.
That's amazing, and I think that's a good moment to transition to the two technologies we haven't talked a lot about yet, which are digital health and sports tech. And I think we can kind of bounce back and forth between those because there's so much overlap. But I wanted to kick this off with asking, we see this world moving so quickly. We were just talking about China and education. Health technology has always moved a little bit more slowly for some pretty obvious regulatory reasons.
Yeah.
And also, I think, because there's a certain degree of probably healthy, pun intended, skepticism about relying on technology to help us with our health decisions. So, I think, actually, Shiva, in a way, sports technology helps with that, right? Because people are willing to put on a fitness band. They're not relying on it. They're getting data. What is that development cycle looking like for you and for the technology to invest in?
Yeah, I think what we are seeing is that when it comes to sports, it's our ability to address the two big constituents, the sort of the athlete and the fan, right? I mean, those are the two big parts of that ecosystem. Everything else is sort of a necessary evil in the middle, right? I mean, if you could get rid of most of them, we would, right? So when you think of the athlete, clearly a lot of the technologies around wearables and various other things that you're referring to, the adoption cycle there is rather quick. It's actually surprisingly quick, obviously a little bit dependent on the sport, what country you do it in, and so on and so forth. But the desire to actually use that both to improve their performance as well as address issues of health, whether it has to do with your hydration or your respiration, your various other things that you'd like to monitor while you're in athletic pursuit, is very, very high, right? Now, the other part that is very useful is that in most of those cases, in most circumstances, they are actually quite eager to share the data with us, right? So that, I think, combination of the adoption as well as the desire to share data, which goes back to what we were talking about earlier, allows you to actually iterate on the technology very fast, right? And then I think there's a lot of different aspects to this, but the sensors that you're actually building into what the athletes are using has a much deeper usage addressing the other constituency, which is the fan, right? And what the broadcaster does with it, what the fan actually does in terms of their consumption, what the fan actually builds in terms of their own preference, right? The learning of a particular profile, the application of something like ambient computing when it's specific to sports is actually learning about you. That's really what it is. And that development is much faster in something like sports because in general, people are very open. They just, it's not like healthcare where people want to hide everything. In sports, people actually want to share. People want to tell you stuff. So I think in terms of adoption, a lot of these technologies, both on the sort of the player side or on the fan side, I think it's going to be a lot faster. Except there is one aspect of it. If there is some linkage to the more to the professional athletes in terms of their compensation or how they're going to be paid or whether they're going to be included in the game, and if that data is going to be used for that, then then it runs into trouble. But in all other circumstances, it's actually pretty good.
Is the biggest market fantasy sports right now for outfitting?
Say it again.
Is the biggest market, I've wondered, so fantasy sports, like people being able to get closer?
Yeah.
It's really cool. Jim, so we're talking about this in the sort of the sort of slow ramp of adoption, but I see you have some props. What are the kinds of technologies that, from a health perspective, are sort of the gateway drug for technology?
Sure.
Sorry, I'm so sorry. For medical technology in everyday life.
Yeah, well, it is an exciting time, and it's not 5 years out or 10 years out. It's actually already happening all around us this very moment. In fact, I'm holding up the world's first Bluetooth-enabled home pregnancy test. Imagine that. Now, a lot of people look curiously and say, really? Is sad about being able to upload the result to a Facebook page and make a lot of guys nervous. And then here's the home paternity test. But it's interesting because in reality, this is probably worth nearly $1 billion of cost savings and probably reduction in premature deliveries and other things that we'd love to be able to avoid just by having the result from this connect and save the cost of a duplicate test to go to the doctor. And you're looking at connected inhalers, so every time your child takes a puff of the inhaler, now that information can be immediately transmitted to the pediatrician, to mom, and actually to the insurance company. Now, you brought it up, Lindsey, the importance and the regulatory environment of healthcare, because for better or worse, some of these things can end up killing you if they don't work right, or you look at the explosion of the wearable market in the sports arena, but I think it got called out that even a local wearable company up the street here had a heart rate measurement that was about plus or minus 20%. That's probably not going to cut it for a cardiologist making life and death decisions about your medication. So what's happened is these are now evolving very quickly into medical grade level devices. And a big breakthrough earlier this year was the largest insurance company in the world, United Healthcare, actually developing a proprietary wearable that's highly accurate, on which they actually created an entire health plan design that's now been launched nationwide. And this wearable that they give you as part of the insurance program allows each individual to be able to earn $4 a day, $120 a month, $1,500 per year. So this is real money, cash that gets deposited into your health savings account that you can keep for the rest of your life in exchange for a very specific regimen of activity that they, based on a huge data base and analytics that took 4 years and millions of records, to be able to look at the outcomes and the health benefits of that program and balance the economics. And it's just the beginning, and this has already been rolling out, and you're looking at hundreds of thousands and soon millions of people where they're going to be improving their health getting the incentives and reducing costs across the system.
So, Shiva, do you think that the work that has been done in the sports and specifically in wearables and the sort of personal fitness tracking world have laid the groundwork for the medical device manufacturing and data work that's happening now? Has that been a predecessor?
I think it may be too early to tell how this thing is actually going to play out. But one thing that is clear, and as Jim just alluded to, I think the ability to take out a new piece of technology and quickly test it out in a non-medical setup, and the linkage that it has with what might potentially lead to a real medical use, clinical use type device, I think that does exist. For instance, the FDA actually lets you get away with blood pressure monitoring, even if it's plus or minus 10 or 20, right? So it's not. I don't know. I forget if it's 10 or 20, but it's a pretty high number. When I first read it, I was actually quite surprised, and I actually had somebody check it. And I think some of that has to do with the fact that there is a range of uses, right? There are certain set of uses for which you can put the technology out, test it, refine it, and then, of course, ultimately, if they're going to take it into an ICU, I don't think they're going to allow that kind of, if they want a FDA, level 1 certification, then it's a different ball game. So I think it is logical that we'll sort of head in that direction, but I don't think there's enough proof points to actually say that that's what will happen.
I actually see as much linkage with the automotive space and the healthcare space as probably exists.
Absolutely.
With the fitness tracking, just because a car is life or death, whether it stops to either for a pedestrian or if you're for you inside of it, as well as sort of pieces, mission critical pieces where we have sensors collecting data, and a lot of that comes over from the aerospace industry, where they have sensors on landing gear. They have Boeing and Airbus and Lockheed, and so while obviously as individuals we want our health to be tracked most accurately, obviously we want our what's carrying us from point A to point B to be accurate and not within 20% margin as well. The other interesting question that's being brought up in automotive as well as healthcare is insurance rates. Like, I haven't done a 23andMe because I'm afraid that when somebody buys that company, they're going to have my data, and somebody is going to get and you can probably tell me that it's actually going to end up in your favor. But Ancestry.com I see is advertising a DNA test now too. If it's all going to go there anyway, I should probably just get a test, right? Same is happening with driving. You can plug in a fob and you get better insurance rates theoretically based on your driving. But I'd be interested to know what you think about on the insurance side of things, how this affects us.
There's no doubt. All of these things are going to create an opportunity to have a better understanding of your behaviors and your potential risk profile from an insurer point of view. And there's also a conundrum around consumers having all this information and they want to throw it at us, and we don't know exactly how to deal with it. Is it accurate? Is it something I want to use? So I think there's going to be a period here of sorting out what data, and then that's the other aspect is the explosion of information, and being able to sort out what out of all this information matters, what information are people willing to share, and then how do I effectively use it. But there's no question, in fact, I use a slide all the time that shows the introduction of the airbag and this steep drop in annual automotive related deaths from 40,000+ per year down to what it is right now, around 30,000 U.S. auto highway deaths per year. And now with the introduction of the autonomous braking cars and the lane changing technology, we're going to see another very nice and measurable drop in the lives saved, or drop in the number of lives lost from auto accidents because of the introduction of these technologies. And right now it's being estimated that in 5 years about 1/3 of traffic highway deaths will be eliminated from where they are today.
That's amazing.
Do you know that the most, just quickly, the most deadly part of your vehicle is the steering column.
Yep.
And that's federally mandated. And so because of that, they federally mandated an explosive on the end of your steering column.
An airbag.
So, an airbag. and we're seeing a lot of failures there, but that gets back to, I think, and we can all address this, Steve Case talks about it in the Third Wave book he just wrote about too, but it's, there's some regulatory issues that we have to overcome because we're causing some of these problems, because you could drive just like you fly by wire. You can drive by joystick, but you can't based on the laws in the United States.
So one of the things that I find really interesting is that there's so much data being generated right now, and there are probably sensors that we don't even know about that aren't turned on yet in certain, I had a conversation once on a panel with somebody from GE, and I was asking about sensors in things like ovens, and he was saying we put these, we put sensors and we put all kinds of future thinking parts in our appliances, even the white label stuff, so that we can turn them on later. So there's all of this potential data collection, and I'm wondering how things like Watson or like big AI engines are actually potentially able to identify patterns for us that we don't even know we're looking for with all of that data.
Yeah, I think part of that is, and it gets back to a comment about iterative planning. Mm-hmm. I think you're going to see the sophistication of, call it the AI, improve, but there will also be those that try to leap so far ahead but won't have all the parts to make it real. Yep. Mm-hmm. And we've seen Tesla experience a PR problem around that recently, right? The other things so there are lots of interdependent pieces, and there are problems that still have to be solved, even though we can all see the vision. And some of those get back to the data is one. For example, being able to change lanes or stop really quickly will depend on knowing about what the 10 or 15 cars ahead of you are doing. Yep. And each of those cars need to be somehow integrated so that your car knows what to do, for example. In order for, say, my personal health information to be leveraged to help diagnose anybody else's, I'm going to need to be able to control my data better than it is possible today. So, for example, one technology that we are doing a lot with clients in the garage today is blockchain, which some of you may be familiar with. Bitcoin, it's in financial services, but what blockchain really is a distributed trust network. Right. And you can begin to think about how a distributed trust network could be leveraged to help consumers control their both holding on and giving up of their information, so that whether it's diagnostics or clinical trials or other things in healthcare, or how your fans and your whatever, then that's what's going to be required for those more advanced use cases to be achieved. Jim,
Jim, we're going to go to your comment, and then after that we'll have just a few minutes for audience questions. If anybody has one, you can line up at these two stand mics. So you can do that now while we're talking, and then we'll spend a few minutes letting you guys ask questions. Go ahead, Jim.
Well, this also raises the issue of moving from what's currently about 14 billion-ish connected devices to what's likely to be 50 billion or more connected devices in the next 5 years. And our existing data network is nowhere close to being able to handle that. And especially both in healthcare and automotive in particular, what are called the mission critical concerns, and our 4G networks are very ill prepared to be able to deal with something like that. I think what you're going to start to hear, even at CES in a few months, is the emergence and the reality of 5G. And it's probably important for anyone in this business to start paying attention to what that means. And it's pretty exciting, because 5G is going to be, and is, designed specifically to support a world of 50 billion connected devices with a lot of mission critical capabilities, like a latency less than 1/10 of a millisecond, and a packet loss of less than 1 packet in 100 million packets, and about 3 gigabit per second type of bandwidth. And it'll take a little while to roll out, but you'll start to see pieces of that going live even towards the end of next year. And by about 2020, this type of capability, and when you start talking about augmented reality and virtual reality and autonomous cars and healthcare that's going to be managing your diabetes from a wearable Medtronic sensor that's going to rely on cloud-based algorithms, that you need that reliability, that ultra-low latency, and so forth.
I also need it to hurt less.
And it hurts less, yes. So it's an exciting time. Start listening for those kinds of developments, because you're going to want to skate where the puck is going and not be building things to what exists today as far as the network performance and bandwidth and reliability.
Great. Do we have any questions out here? Go for it. Right there. You.
Can you hear me? Thank you. I enjoyed your answers, learned a lot. So I'm interested in learning about your thoughts on how we can help sustainability and climate disruption with AI. And maybe each one of you can just say a little. I know Justin is giving a talk, but if you can just tell more. Thank you.
Who wants to jump in first?
Sorry, the question is with AI?
With AI, yep, sustainability. Anybody want to?
I guess I'll comment. I know that, and I haven't read a lot about this, but there are bits and pieces. One of them is that, and we've talked about IoT, but there's the collection of data, which is being done in a lot of different ways. So for example, and I can't remember the name of the company, but there's a really interesting company that's building basically a submarine that goes through the oceans and is basically capturing data on an ongoing basis. And and of course it's feeding it up to the cloud. So I think that trend will happen where more and more will become, call it instrumented, or meaning more sources of data. And then, for example, IBM, we recently bought the Weather Channel, and that's for a very specific reason, because we know that there's a big source of data there. And so there is a whole area by taking and how to correlate, and this back to Jim's point, this massive data that you couldn't figure out by yourself, but then be able to apply algorithms to provide more artificial intelligence to glean things from it. It's a little bit of a different, meaning it's geologic scale as opposed to, let's say, how is my blood pressure minute by minute? But the size of the data is proportionately larger as well. So I'd say that those two things, once again, the data points that the data is coming from are increasing, and the ways to analyze it are improving as well. Now, will that change humans' ability to decide and make policy? I won't comment on that. That gets into politics.
I would say it's an interesting question. So the number one cause of greenhouse gases and global warming is animal agriculture, more than all of the ships, all the cars combined in the world. So you can do a couple things about that. The world can stop eating meat. Maybe you can come up with AI to, create a great marketing campaign on that. Or there's companies like Memphis Meats who are creating, mock meats that are like real meats, and even growing meats in labs that are, on a cell level the same as the animal protein. So you can certainly apply artificial intelligence and machine learning to creating, better alternatives, and I think that could dramatically change things. There's also the promise of AR sort of helping with sustainability. There's a lot of physical objects that will no longer be needed. There's a lot of additional electronics that will no longer be needed when you can essentially create virtual alternatives to those things. So I think there's a lot of promise for making the world a greener place with AI and AR in the next decade.
I think in this instance, we often say we miss the forest for the trees. I think in this case, the opposite is probably true. Because we can actually now instrument so many things in very, very specific detail, I think when it comes to agriculture or understanding how the forestry works or what we have to do with the ocean of the future and all of that stuff, I think our ability to actually sense and collect all this data and actually apply it to something that is, leads to sustainability and various other things in terms of use of resource is now possible. I think previously we had to look at things in the aggregate. And I'll give you an example that might, make this a little bit more concrete. One of the biggest waste of resource that actually happens is how irrigation is done today around the world, right? Irrigation is done incredibly broadly. You have large canals that carry lots of water, and you irrigate large fields. The plants and the agricultural whatever you're growing doesn't need most of that water. Water is actually needed in very, very specific times in very specific quantities. Now, you cannot regulate that if you're not able to actually monitor each one of them very, very specifically. So there are many companies that are actually now experimenting with how do you actually cut down water usage, not by 10% or 20%, but by 99%. And we can do that only because we are actually able to gather all this data at a very, very high level of detail. That's just an example, but I think we are heading in that direction where sustainability will be driven by the fact that you can actually gather an incredible amount of data and then be able to analyze it.
We have 1.5 minutes left, so I want to leave time for anybody else who wanted to ask a question. But if not, I will...
There's one hand up there.
Oh. All right, come on up.
Hurry!
Hi guys, my name's Andy. Thank you, that's been great so far. We talked a lot about all the wonderful potential that big data and AI and AR have. How about some of the inherent risks and challenges that are associated with it? What are the kind of hurdles that have to be overcome with things like worrying about data being hacked, and as more information about us is out there, there are problems with that as well as opportunities. We want to hear your thoughts on some of the problems and challenges.
Woo, we got 30 seconds for problems. Who has the biggest problem?
I think you just named them.
Jim.
Privacy, sensory overload.
Healthcare has obviously got a lot of attention, and I think sadly right now it's a little bit of hysteria mixed in with some reality, and it's just like anything. The risks are always going to be there. The question is, how do you balance the benefits against those risks? And until you're experiencing these benefits, the only thing you see is the risk, and that gets a lot of attention. And so you're going to start to see the greater and greater benefits to conveniences, to not having to drive your kid to the pediatrician and sit in a waiting room with 20 other sick kids and being able to do that at home, but that means that data has to flow digitally, and you'll know that has a certain inherent risk, but you're certainly willing to accept that risk because of the alternative risks of driving the car to the pediatrician and sitting your kid in the waiting room with all the other sick kids. It really is a balance, and the risks are never going to go away, but what you want to do is drive up those positive benefits and make a choice on an individual basis and on a society level basis.
How about the people who like thinking for themselves and like driving? Like, I like driving.
Yeah.
I like thinking, and I'm not saying other people don't, but that's, to me, sort of that autonomy as a human being starts to be.
Enjoy it while you can.
Yeah.
Yeah.
All right, and on that note...